Imagine this. You've poured hours of work over the past couple of weeks into a group project. Your contributions build the foundation that make the entire thing possible. But when it comes time to present your hard work, all anyone seems to be able to focus on is the efforts of your teammates, while yours go completely unnoticed. Not a great feeling, right? Well, this situation is far from hypothetical. It was the reality of a brilliant scientist who played a pivotal role in the discovering of the structure of DNA. But for decades, her contributions went unnoticed, her name barely mentioned in the story of one of science's greatest breakthroughs of the 20th century. Today, I want to tell you her story and pay tribute to her discoveries. Rosalind Franklin was born in 1920 in Notting Hill, England, to an affluent Jewish family. From a young age, she had a clear vision of her future. She was determined to become a scientist, even at a time when this ambition was far from typical for a woman. She went on to earn her PhD in physical chemistry at the Cambridge University, focusing on an invisible and intricate world. She specialized in crystallography, the study of how atoms and molecules are arranged in crystal lattices. Imagine a lattice pie crust or a chain link fence. They have regular, repeating patterns. That is what Franklin examined at the atomic level using a technique called X-ray diffraction. This technique shoots X-rays through a crystal to produce the patterns that reveal a molecule structure. It was cutting-edge science, and Rosalind Franklin was at the forefront. She used this technique to study more complex substances as opposed to just single crystals, which is what all the technique had been used for previously. In 1951, Franklin joined King's College London as a research associate. There, she applied her X-ray diffraction skills to a new molecule full of mysteries: DNA. Working alongside her PhD student, Raymond Gosling, Franklin captured many photos of DNA fibers using X-ray diffraction. The most famous of which, known as Photo 51, provided undeniable evidence of DNA's helical structure. However, in a dark turn, a colleague at King's College shared Photo 51 without Franklin's knowledge to James Watson. Watson and his partner Francis Crick used Photo 51 as the basis for their own DNA model. They published their findings in 1953, and their names went down in history. Franklin's own paper was published in the same issue of Nature's magazine, but it was seen as supporting evidence as opposed to the foundation. Watson and Crick went on to win the Nobel Prize, while Rosalind Franklin remained in the shadows. But this is not the end of Franklin's story. After leaving King's College, she began studying the structure of the tobacco mosaic virus, a plant virus. Her work laid the foundation for what we now call structural virology, the study of viruses at the molecular level. This work also led to the discovery that RNA is a single-stranded molecule. She tragically died at 37 from ovarian cancer, but during her short time on this earth, she transformed our understanding of life at the microscopic level. Hopefully, I've helped shed some light on the brilliant scientist and woman that was Rosalind Franklin. While her name may not have gotten the recognition it deserved in her lifetime, her legacy shines brighter than ever today. Franklin's meticulous work and sharp insight were essential to one of scientists' most important discoveries. That discovery laid the groundwork for genomic medicine, helping us understand genetic diseases, develop life-saving therapies, and unlock the blueprint to life as we know it. Her work studying the structure of viruses also contributed to similar medical advancements. In honoring Rosalind Franklin, we're not only giving credit where it is long overdue, we are also reminding ourselves of the importance of integrity and of recognizing the voices of those who were once left out of the story. Thank you.